Yeah, okay, well, see, that's dividing the human head up into basic planes. And that's very, very important to drawing, to be able to do that. How do you do it? You got to think in terms of simple shapes. You got to think of a ball, and maybe a cylinder, or maybe a cube, or whatever else, to be able to get that basic structure. Another word for it, you've got to be able to look through this and see what it looks like on the other side and see how it's going to change. You got to have X-ray vision. You develop X-ray vision. And how do you do it? By doing this simple shape business and learning how to cut them up into different slices and see what happens. It's called structure. I use the term structure for that. You can call it architecture, construction, X-ray vision, form, planes, whatever, but get the idea. It's that wireframe business we talked about last week that computers know how to do. If you can reduce things to simple shapes, you will not have trouble with the fact that almost all lighting is poor lighting for bringing out form. The worst lighting for bringing out form is flash bulbs on cameras. When they're on the camera, it flattens the form out. But see, if you know the simple shape, and you know just some basic rendering, then you know that if the light comes from this way, which angle exactly? Core shadow will be right there. Everything to the left of that will be either shadow or reflected light. Highlight will be right across that edge, and you'll have a subordinate highlight there. Say, gosh, I don't like that lighting because in my composition, I want the dark part to be up here because I need more dark up here. Easiest thing in the world, throw the light down there. I can put the core shadow over here if I want to. Or I can say, I want the light behind it. If you put the light behind it, you know how to put a rim light right there. And know just how that curves and how that core shadow is going to be. And you do that from the whole head, down to the nose, down to the nostril, down to the eyelid. And then you get defined form. And you don't even need a model to do it. A model will help give you inspiration, but you won't be bound by it. Okay, the picture plane. We have to understand what perspective is doing. We are pretending that we're looking through a window when in fact we are just looking at a flat surface. The picture plane, let's say this is what you're drawing. That's your painting. We're pretending like it's a window and that there's stuff through there. Now that means the window, there's rules that we have to do about this window, that you're looking through a window. For one thing, the window has to be perpendicular to your line of sight. You know that word now. That is, it's got to be parallel with my eyes, like that. Perpendicular to my line of sight. If it's not, if it's like that, it's not going to help us for perspective. It will help us for some other things, but not perspective. It's got to be perpendicular. So you can imagine, if my head goes like that, it's got to go like that. You've got to have this thing tied to your head. Then you've got to imagine that there's a grid on there. That window, because you might be drunk or something, or you just might not have eyesight, you've got to have something objective to measure. You want a grid on there. You want a grid of squares, because squares are simpler than rectangles. And if these squares down here all conform to those squares, then whatever you see, if you see a curve right there, you'll know there'll be a curve at the analogous square down there. So it's like you're painting on a window to get that effect. Now there's another problem that runs into this. We're trying to make it as simple as possible to use this window metaphor to get the illusion on our paper. You've got two eyes, which is great. I mean, it's useful for depth perception, but it gets in the way for doing this optical illusion trick, which you remember when you were a kid and people said, put your finger up to your eye and look at the moon. Now, you notice how there's two moons, or if you look at your finger, there's two moons, and if you look at the moon, there's two fingers? That's because you got two eyes, and you can focus on one and the other one splits into two. Focus on the other, this one splits into two. So, to simplify this, you have to have one eye. You've got to cover one eye, and then you've got one point from which you're looking through this window and finding points on here and going on to that. Now, if that sounds kind of, gosh, that's awful scientific, it helps to understand this picture plane. It even helps to build one. plexiglass with felt tip marker marks on it like that, and you'll start to see, if you look through it, you'll start to see, oh, I get it. I get what this is about. We're supposed to be looking through a window into another world. Knowing this explains a lot of perspective problems, one of which I want to show you now. Let's take this picture plane and look at it like that. Look at the edge of it. Remember, I'm looking at it like this, but tip it up so it's going like that, and we will have this edge like so. There's the edge of that picture plane. Now, we'll put somebody's face right here. There's their nose, there's their ears, and let's see, there's their hair. It's too much hair. Take a little of that out. And this person has an eye patch on. We got to give him just one eye. Okay, that's the eye we're going to use to make this point. Now let's take two pencils of exactly the same size. This is exaggerated to make a point. We'll say those are pencils. Exact same size. And I want to show you what happens with this picture plane. If you run a line from this to this, straight line, and from that to that, do you see what's happening there? Look at what this pencil looks like to this eye. Do you see that line and that line where it intersects? It's going to be that long on the picture plane. Now look at what that pencil does. It's further away, same width or same length, but look what it does. Because it's further away, the angle of vision is more acute, right? Which means that it takes up less space on the picture plane. Does that make sense? So now let's erase this character and take the picture plane now and tilt it like that and watch what will happen on that window of the picture plane. This pencil here, which has intersected at those points, will be that long. This pencil here, which is intersected at those points, just drop those lines down, will be that long. I know it's complicated. It gets very complicated when architects do it. Although they have ways of simplifying it. I mean, there's only height, width, and depth. So you've simplified it by making it, there's three things you got to deal with. There's height, width, and depth, and there is nothing else. There's nothing ethereal. Just the height lines, the width lines, and the depth lines, and you got three dimensions. Whereas all I did was width lines, or apparent width lines, actually length lines, major axis. But you see that this idea of looking through a piece of plexiglass and that you look out at things and they make little points on there explains why this illusion of diminution and convergence happen. And it also explains why overlapping happens, but I'm not going to take the time to analyze it because you could probably figure it out yourself. One more thing. The picture plane is something that we will allude to. And then another thing that really helps in knowing perspective is knowing multiple views of an object. I had no idea why it was valuable before I knew perspective, although I'd heard people say so. Let me demonstrate the problem. Do you remember last week when I was showing you John Nagy's simple shapes and how if we were to take these things off of here, that when we took this one off, it turned into what? A box? Do you remember what somebody said when I was going to say when we take that one off? Do you remember what somebody said, what somebody called that? They said that would be a box. And when I pulled it off there to show what it was, I said that it was a cylinder. Well, you know, there is no way to know when you look at that whether that is a box or a cylinder. There is no way you can know. But there would be if I had done what? If I'd have shown a top view of it above. And if I'd have shown that that top view was like, oh, no, let's say that top view, make it a little more square to make the point. If the top view was like that, then you'd know something, wouldn't you? It's a 2x4, a chunk of a 2x4. If, on the other hand, same piece, same view, If the top view is like that, that means if I turn it like that, it's got to be a cylinder. It's got to be a cup or something. And then I'll know that it looks like that when I tip it in space. But I still might be wrong. There's one other view I need to know. You say, has it necessarily got to be shaped something like that? No, there's another way it could be shaped. If you were to see the side view, and the side view went like this. Let's do it like that. That means, I want to make this even a little more extreme. Let's make the side view like this. Do you see? This can still be a circle, right, if you tip it up. But it means that the bottom down here is going to go like that. And that's a confusing shape. What is that? Well, it's confusing because there is a transition going on somewhere from circle, and so here's what you've got to do. You got to do what we talked about last week. You got to be able to wrap lines around every bit of that and define it. And I'm going to do that to explain the point. Would it help if I work bigger? Can you see this? It's okay? This up here is probably going to be basically round. This down here is going to be basically flat. There's going to come a point in there, though, where those lines are going to straighten out. Now, do you see? That now defines that form. Or let's say that you aren't going to put rubber bands around it. Let's say you want to light the thing. Let's say you want to make it a plaster cast. Look at what you can do. Let's tilt that thing away from you like that. Now, if I'm going to render this with my airbrush or whatever else, or paint, look what I'll do. I'll make it so that the core shadow there is going to be soft, because shadows on curved surfaces are soft. That is, if you've got a block like that, and you've got a light coming down this way, you've got a hard shadow there. If you've got a cylinder in the same position, you've got what kind of shadow? You've got kind of a blended shadow. So that means your shadow is going to go from soft, at some point, it's going to just be a hard line. If your light's coming from that way, that will be the shadow part. If your light's coming from this way, that'll be the highlight part, and the shadow will be over there. That's why architects use those three views. They have a plan, a floor plan, and they have a side elevation and a front elevation. And you can give them blueprints of that, and they can do these marvelous three-dimensional renderings that show everything looking as if it was in space in a three-quarter view. It's just a method that they go by measuring everything and putting them through the picture plane and working it out. Any questions about this? Does it make sense? Is it overwhelming yet? No? So you followed this? Because I want to tell you how we're going to approach the semester as far as what we're going to cover. The next 3 weeks, all we're going to talk about is how right angles are affected by perspective, which means the cube. Basically the cube. Railroad tracks are right angles. Park benches are right angles. These desks are right angles. The structure of this thing, even though it's got curves, is based on right angles. This is right angle. This chair is right angle. The door is right angle. The whole stinking room is right angles. The city is right angles. Everything humans build are right angles. So that's what we're going to do, is worry about right angles and how to put them in perspective. That's where you get the stuff of 1-point, 2-point, 3-point perspective. That applies to right angles. Okay. We're going to spend the next 3 weeks after that on circles and ellipses. On circles. Ellipses are circles in perspective. There are circles everywhere in nature and variations of the circle. The spiral is a variation of the circle. The helix is a variation of the circle. But we're going to study circles. Because circles are tough. Circles turn into ellipses. Circles tip in space. Spheres are a billion circles, an infinite number of circles all kind of clumped together. You got to know how to draw a sphere if you're going to draw the human head or an eyeball. A lot of people get into trouble because they don't know how to construct ellipses. You can see it when they draw eyes. You can see it that they don't know how to make the eyelid wrap around a sphere. Then, the weeks after that, at least 2 of the weeks after that, we are going to do right angles and circles get married. Why? Because it's a big problem. This door is made up of what? Right angles. As soon as you open this door, it's doing a what? A circle. The pivot right there, it would go in a perfect circle all the way around. So when you're going to draw doors that are open, it's like, how do you do that? You've got to track the circle that it would go in perspective, an ellipse. You got the same problem with cardboard boxes. Cardboard boxes are what? Made of what? Right angles, until you open up a flap. And when you open up that flap, it is a perfect circle, though only a portion of one. And if you can track that circle as an ellipse, you can kind of track along the line where that flap will go. A lot of problems solved with this right angles and circles combined. And then we're going to get into stuff that is some of the most liberating and wonderful stuff about perspective. It's depth measuring systems. How do you measure things? What if you're doing a tree-lined street, or what if you're doing a picket fence? And you want that picket fence to be pretty systematic. It's going back. How do you measure so they get smaller at the right angle? When you do those railroad tracks and you do the ties and they get smaller, you have to take a picture. No, there are specific ways, scientific ways to measure things that go back in space equally, or for that matter, unequally. I'm going to give you 5 systems. It's easy to measure across. It's easy to measure, turn that into checkerboard, but what happens if you got to measure back there? What happens if you've got a logo or something and you got to tilt it in space like that and you don't have Photoshop to do it for you? Or you don't want Photoshop to do it for you because you want it to be what you want it to be. There are 5 systems of measuring. 2 of them are great. 3 of them have certain limitations. I'll go through all 5 of them over a period of 2 or 3 nights so that you'll understand how to measure things back in space. They're tricks. They're just tricks that you use. And they're accurate tricks. They're scientific tricks. And then we will spend, I'm not going to bother to write it down. I just mentioned it. We will spend time talking about the picture plane and plan projections, a little bit about what architects do. If we have time, I'll try to give you an explanation of it, but I'm not going to get too much into it because you need to go to the books. But if you've tried to go to the books and been confused, I'll spend an evening trying to explain how architects take those 3 views and turn them into something 3D. We'll do it with something simple like a cube. This will be one step at a time. I sympathize with you. I never felt that I had a talent for perspective, but I felt a deep need to know it, and finally plunged into it as a teacher to learn it, because I wanted to create drawings that looked like they had space, and I wanted to do it without all the limitations of having to take pictures first, and also do it with the kind of effortlessness and integrity that master draftsmen had. And when you were learning to do your ABCs, when you were learning about not just the letters, but also how they come together to form words and all these crazy rules in the English language, could you ever imagine that there was a time when you'd be able to pick up a book and read a paragraph without stumbling over that B looks like a D and all that? When you read, you don't even think about letters. If you're a good reader, you don't even think about words. You think about what the person is saying. And it's a vehicle that has become effortless. And it became effortless partly because you had this theory that said rule 1, rule 2, law of this, understand diagram, sentence, spell correct, B is shaped like this. All that theory and stuff. But the real way you learned it is that you did it. and you did it, and you did it, and you did it, and you did it, and you did it for thousands of hours, and it became as easy as breathing. That is what happens with perspective. There's a few things in there, the obtuse, acute, the tipping the thing in space, that have become easy enough for me to where they're as easy as I can do. I fail sometimes in front of you so that you'll feel good. But they do get easy. Spiral staircases, I don't think spiral staircases will ever be easy for me. I don't care if they are, because I'll do preliminary work. You know, I'll work it out on a tracing paper first and do all of my struggling there, and that way when I get to my finished piece, the scaffolding has taken care of all of that under stuff, and then I can make it easier on the surface. Any questions about this?
This is a blood pump that I illustrated a number of years ago with airbrush. The preliminary drawing looked like this. As complex as this seems to most people, it is in fact the ability to draw a box and a cylinder inside a box, and then for the gears, little box forms around cylinders, done over and over and over, that creates this apparent complexity. In other words, the drawing is built entirely out of simple forms that I apply down to smaller and smaller levels until the completed machine is drawn. Then I render it. This is figuring it out from the inside out and then choosing to light it.